All right, hey gang, glad you're joining me today. The reason why I'm making up this video is because I didn't know if I was going to be able to get through all of the lesson, all of the terms and everything in class on, well, whatever day you have me. And so I wanted to make sure that if I didn't get through everything, that you had the opportunity to finish the lesson with this tutorial. So I'm gonna be honest, the terms are gonna take much longer than actually understanding the content that we're gonna get to. So bear with me. So anyways, let's get right into it here. We are in section 1.6, two-dimensional figures. And what I've done here is I've just kind of, how do I want to say this? I've written down all of the terms for you, and you can go ahead and jot those down so that you have them in your notes as well. I'll be honest, I don't really like the definition they give you of polygons. I probably should have used the one from the old textbook that we used to have. But here's what it is. Polygons is a closed figure formed by coplanar segments whose sides have the following conditions. Okay, now if I'm going too fast, feel free to pause. But I'm going to continue to talk about polygons here, and I want you to think through this with me, but you want to have this down in your notes. So the sides are two consecutive sides are non-collinear, and what that means is that you can't have two sides that make up a straight line. They have to have a kink in them, a bend in them, all right, which forms the vertex of the polygon, and you guys have told me you know what a vertex is, okay? The second condition is that the sides intersect each other only at their endpoints, okay? So you should be able to clearly identify how many sides the polygon that you're looking at has. So when I take a look here at my polygon, okay, my polygons and my non-polygons here, what we see for the polygons, they're all closed, and this all comes to an end right here. They intersect only at their endpoints. And no two consecutive sides are collinear, okay? So these are all polygons here. This over here is not a polygon because it isn't closed, okay? This one isn't a polygon because the endpoint doesn't occur right at the end. This isn't a polygon because the sides have to be segments, okay? I underlined that up here in my definition. They have to be segments. They can't be curves. And this one isn't a polygon because the intersections take place not at the endpoints of the segment, okay? So again, just different types of polygons, and make sure you know how to recognize a polygon, okay? Now, the different names of a polygon are down here, okay? And so the different names of a polygon, you should probably know the first 6 of them pretty easily, okay? 3-sided would be a triangle. 4 is a quadrilateral, 5 is a pentagon, 6 is a hexagon, 7 is a heptagon, 8 is an octagon, 9, my personal favorite for some odd reason, is a nonagon, just like that name. 10 we know is a decade or a decagon. 11 doesn't get used a whole lot for some odd reason, but we call it a hendecagon. Now, I'll have to see if hen is some sort of Latin for 1, because when we go to 12, it says a dodecagon. Now we know do meaning 2, okay, and deca meaning 10, and so 2 plus 10 is equal to 12. The last one is an n-gon. Now you might be thinking, why is an n-gon included in the polygon here? Here's the reason. The n-gon is included here because after you get to 12 in your textbook, or really any other textbook that I've ever seen, they pretty much don't write down the name anymore. They're like, yeah, we've punished the kids enough through 12. So what happens after 12 is they just write down the number and then the gon. So, you know, if they want to do a 20-sided polygon, they're talking about a 20-gon. A 30-sided polygon is a 30-gon, so on and so forth. So just something to think about there, okay? Now, as we move on to some other terms here, okay, these will be very important as we work our way through geometry. I'm not going to say that they are going to last, you're not going to use them all the time, but they do get used quite a bit. So equilateral, I need you to know, is 2 parts of a word, equal and lateral. Okay, now lateral means sides, so we're talking about equal sides. So when we say all sides are congruent, we're talking about each and every single side has the same length. okay? So equal sides, equilateral, okay? So knowing that, if we look at the term equiangular, okay, we have equal angles. So all the sides are congruent in an equiangular polygon, okay? So equilateral polygon, equiangular polygon. When we have a regular polygon, these two got married, okay? An equilateral and equiangular polygon forms a regular polygon. And so all sides and angles have to be congruent, okay, in a regular polygon, okay? Now also in this section, we're talking perimeter and circumference. These are both, circumference is actually a form of perimeter, but perimeter is the distance around an object, okay? The distance around an object. Okay, so if I want to know the perimeter of the school property here, I would add up all the sides that make up the sides of the property, and I would have the perimeter of the property, walking the perimeter. Okay, so I just put down sum of all sides. That's just how I remember that. That's just the easiest way. Circumference is the perimeter of the circle, so it's the distance around the circle. Okay, so again, remember perimeter is the distance around an object, circumference is the distance around a circle, okay? Now, as we transition just a couple more terms, and I hope perimeter, circumference, even equilateral, I think you guys have heard before, okay? So, if we're talking area, you guys have calculated area before, and you know, simply put, if I go ahead and draw an object, actually, let me draw a rectangle, that'd be the easiest thing, okay? And an area, I want to know how many square units are in this figure. Well, let's say there are 2 square units down here, and let's say there are 4 up here. I'll try to space them evenly. 1, 2, 3, 4. Okay. So what's the area of this rectangle? It is 8 square units. If I count up the number of squares within the figure, I have the number of square units, the area. So the number of square units needed to cover a surface is considered the area. Okay. Formulas that you're going to need to know. One would be perimeter of a polygon, which is just the sum of all sides. You guys should already know that. Circumference is pi d, or 2 pi r. Now remember, we should probably review this. When talking about a circle, the length from the center to the side is considered the radius, and the distance from one side to the other through the center is considered the diameter. So how much bigger is the diameter from the radius? Well, it's twice the size. And I would assume that you guys know that already. So this formula for circumference, pi times diameter, well, if you think there are 2 radius and 1 diameter, twice the radius times pi would be the exact same formula, okay? The area of a rectangle is base times height. A triangle is half of a rectangle, so that's why it's half, base times height. And circle, the area formula is pi r squared, okay? So there used to be a song that a lot of kids that used to come in from the gifted program would tell me they'd learned. It was pi r squared sounds like area to me. When I think of circumference, I do pi d. So if you can remember that catchy little phrase, pi r squared sounds like area to me. When I think of circumference, I do pi d. So I know I'm trying to sing and I shouldn't, so I apologize. Anyways, that's the terms. So I would assume a lot of those terms you guys have had before, okay? And actually, I think I forgot to do one pair of terms, okay? And I'll cover that here in a second. It's not a term that we're going to use a lot in geometry. So with that being said, we're going to take a look at a couple of these problems here just to make sure you are okay with everything. So looking at number 1, it says name each polygon by its number of sides and then classify it as convex or concave and regular or irregular. Okay, these are the 2 terms that I forgot to write down, and I'm not going to go back and write them down because we don't use them a whole lot. But I want you to highlight the word cave here. Okay, these type of polygons have an indentation or a dent. Okay, a cave, an indentation, or a dent. All right, the convex polygons don't. Okay, So as I look at number 1, if I was to ask you, is this convex or concave, I would want you to say concave because there's this indentation. It goes in towards the polygon here. So I'm going to put down concave, okay? And is it regular or irregular? Well, remember, regular has to have all sides that are congruent, and you can tell by looking at these congruency marks, not all the sides are the same length. And the angles aren't the same measure. This angle is much more acute than this angle right here, which is obtuse. So I'm going to put down irregular. Okay? All right, now, for numbers 4, 5, and 6, we need to find the perimeter and area of each shape. Okay? Now, if we look at number 6, this one is a triangle, and the area of a triangle is 1/2 base times height. Now, the base and the height have to be perpendicular to each other. We're going to talk much more about this later on this year. And perpendicular means to have a right angle. So even though it's not shown, I'm going to tell you that this is a right angle right here. Okay? So when we talk area, we want to say 1/2 the base times the height, because these two lengths are perpendicular to each other. 8 times 7. 8.1 isn't perpendicular. So if I work this out, 1/2 of 8 is 4. 4 times 7 is 28. We're looking at 28 square millimeters there. Okay? Now, as far as the perimeter is concerned, remember that's the sum of all sides. So I'm going to do 8 plus 8.1 plus 8.1. And that's going to give me 24.2 millimeters, okay? It's not an area, so we're not talking square millimeters, just millimeters there. All right, now to finish things up, let's see here. Let's go ahead and look at, I hope I don't choose the easier one. Let's look at number 8 here. I'll try number 8. We have to find both the perimeter and the area of this shape right here, okay? So if I start with S being at 0, 0, we have T is at 3, -2. 1, 2, 3, 1, 2. Okay, and U is at 8, 0. 1, 2, 3, 4, 5, 6, 7, 8. 8, 0. S, T, and U. Okay? Now, before I go ahead and actually do this problem, I'm going to go back to number 7 just to make sure that that's the harder of the two. So as I look at number 7, okay, I'm just going to graph this out. 1, 2, 3, 1, 2. 1, 2. Oh, sorry. 1, 1, 1, 2. 1, -4. 2, 3, 4, and 3, -4. 2, 3, 4. Okay. So yeah, I've definitely got a harder problem back here on number 8 than on number 7. Okay, so let's go ahead and look at this here real quick. And what we're doing here is we're finding the area and perimeter of the shape that we've just graphed, okay? So I am going to, first of all, find the area because it's going to be a lot easier than the perimeter, okay? The area, remember, of a triangle is going to be, I'll put a triangle down here because that's what we're finding, 1/2 the base times the height. Now, the base and the height, as I just said a moment ago, are perpendicular to each other. So I'm going to go ahead and do 1, 2, 3, 4, 5, 6, 7, 8. This is a length of 8. And the segment that's going to be perpendicular is going to be this one right here, okay? It has to come from the opposite side vertex, and it has to drop perpendicularly to the base. So as I look at this, if I count this, because I can count horizontally and vertically, this is a length of 2. Excuse me. So if we do this, base times height, that should give us the area of that triangle there. So 1/2 of 8 is 4. 4 times 2 is 8. We're looking at 4, and I'm going to write this like this. Instead of units squared, I'm going to say square units. Okay? There are 8 little squares, 8 of these little squares here that would be inside of this shape, okay? Even though there's partial ones, you know, here and here, you know, a total of 8 squares inside that shape. Now the next thing is this. I want to find the perimeter. Okay, now remember the perimeter is the sum of all sides. Well, I know that SU has a length of 8. Okay, so I'm going to start with that. But I need to figure out ST and TU. Okay, now how are we going to do that? Well, we have the distance formula. We can go ahead and work that out. So if I work this out with ST, here's my distance for ST. I'm going to go ahead and do x minus x squared and y minus y squared. Okay. Let's see here. X minus x, y minus y. Okay. So if I work this out, we're looking at 3 squared, and we're looking at negative 2 squared. Okay. Now, 3 squared is 9. Negative 2 squared is positive 4, so ST has a length of the square root of 13. Okay. Now for TU, if I do TU, let's do 8 minus 3 squared, and then 0 minus negative 2 squared. Okay, 8 minus 3 is 5, and 0 minus negative 2 is actually positive 2 squared. So we have 25 plus 4, and TU will equal the square root of 29. Okay? So if I add all those together, all those side lengths, the end result, I'm going to put approximately because this is not going to be exact, is going to be my perimeter. Now, I want you to watch how I plug this in here. I end up having 8 plus the square root of 13. Now, right now, you see how my cursor is underneath the radical? Some of you, your calculators may open up a parentheses. You'll have to close the parentheses. For me, I don't have to. I just have to click out of the radical, which is all I did there was just click the arrow key to the right. Okay? And then from there, I'm going to add 29, the square root of 29. Enter. 16.99, so I'll just round it up to 17 units. Okay. So, yeah, that was perimeter there. Okay, so here's what I want you to do. To finish this up, you're going to finish up the front side, which again, I don't think will take real long. If you notice, let's see here, this is O. Oh, sorry. If I can get this down. This is O, this is P, this is Q, this is R. This is going to be a lot easier problem than the problem I just showed you as far as the graphing on the back side. Okay? So I want you to work through those problems there, as well as these on the back side, and try page 61 for me down at the bottom. You got 2 problems I'd like you to try to work through for me down there. Okay? With that being said, I appreciate you guys listening, and let me know if you have any questions. Have a good day.